Um, Hello, everybody. I hope you have a good espresso after lunch and be here with us. We are going to shake things up. I'm Ioannis. We are going to have a topic today, a different one, about the synergy we had between DevOps and QA teams at GWI in order to introduce synthetic testing internally and build an observability culture for different teams. So, Yassas is in Greek. I know there are a lot of people from Greece in the audience. I'm leading QA team on GWI. Is anybody QA person today? Oh, we have one. Great. We need to speak after. So I'm based in Athens. I love everything that has to do with product and engineering. I really love test automation. And I'm also a Grafana champion, which is an honor for me.
Kalispera. My name is Dionysis. I'm leading the DevOps team. At GWI, I'm obsessed with automations. Just love automating stuff, and I enjoy collecting board games, more collecting than playing. Lately with a young kid. It's very exciting to be here. Thank you.
Great. I think the best thing to approach this talk is to identify the problem we were trying to fix internally. So let's describe first the problem with some questions with the audience. First, I need to know if you have tests in place, anybody in the audience, but you don't get alerts proactively. Anybody? Not you, Dio. The audience, please. Anybody? Oh, we have one. All right. If you have tests, but it's mostly for your backend services, not more end-to-end flows. Come on, man. All right. And if you have tests, but you don't actually measure web performance. OK, we got it. So we started like last year building monitoring metrics with our DevOps team. We wanted to embrace, let's say, observability with all these tools, but we actually didn't catch the issues proactively from production. Our clients were annoyed, and they are actually pinging us all the time. So we started embracing the tools from Grafana Stack, and we were trying to figure out how the QA team and the DevOps team can work together to build a pet project that we're going to show today, especially in the demo, and alert actually our engineering teams proactively when something is happening on production and in time.
Before we have a look into code, let's talk a bit about our stack. No surprises in here. I'm sure you must have heard about these keywords a lot over the last couple of days. Internally, we're using a rhyme to describe these kind of things. So we say that L is for Loki, that tracks our logs, G is for dashboards, T stands for tempo, that traces stuff, and P for profiling when code is daft. And then we have good old Prometheus for all the metrics and stuff like that. Now, not to overcomplicate things, we also have Alert Manager in the background for our alerts. And we also have Thanos for the Prometheus Federation, so loads of things over there.
Cool. But let's step a little, a step back. Let's take a step back and see why reliability is hard. I think everybody is aware in the audience. Complex architectures, our system has around 100 microservices, right? There are different layers. You have the client-facing layer, you have the actual service layer, your APIs, which are the middleware. So we are not like 10 years before. We had a monolith back then, a few databases. Now everything is more complicated. You have different programming languages for each of your layers. You can have different protocols to communicate, like gRPC, HTTP, TCP. So really, it's hard to develop stuff for your product. It's even hard to test stuff for your product, and even harder to monitor, right? But someone would say, like, this is true, but that's why we need to build observability. But it's a little bit more complicated than that.
So let's talk a bit about our high-level solution. Okay. Don't forget that as a DevOps person, it's irritating to push for observability, for monitoring so much, but then you always getting notified first by the client when something goes wrong. So our high-level idea was to take those K6 scripts, those K6 end-to-end tests, and then wrap them on a container, and then wrap them on top of a cron job, and then have them in our cluster running very often, every few minutes. So one of the original things that we wanted to do. We wanted to automate things as much as possible when it comes to Kubernetes. But those cron jobs, because they were running inside our clusters, it means that they had out-of-the-box all the nice observability and monitoring tools that also supported the rest of our applications, which means Prometheus metrics, alerts, and myriad of nice Grafana dashboards. This also means that if a script fails for some reason, then we get notified for it right away, okay? Because out of the box, we have alerts that are connected with our on-call tool of Genie, in this case. And let's say if a user cannot log in, then because our entry point, our first scenario we tried out was users cannot log in our platform, so they cannot essentially use our platform. So then the on-call engineers will get notified proactively for it right away. That was our pet project. It started a year ago during Fridays.
Great. So let's get a little bit technical, do the demonstration about the project. I will start, 1 second, not here. Yep. So this is our pet project. The first thing about the QA team, right? The QA team is a function that, not every company is actually having QA team nowadays, but it's really critical to discuss how the quality engineers are actually embracing the tools that we have from Grafana, especially K6. So the first thing was to discuss with our team internally how we approach the architecture of writing this type of test that we wanted to do with our DevOps team. We use a K6 browser to simulate actions with the browser. And the team already used Playwright. If you know Playwright, it's a web automation framework, so it's pretty similar to what K6 browser actually do, but we used it for our end-to-end functional testing. So it's a different scope. Here we want to measure web performance and see if our application is actually functional. So what the team discussed is to have abstraction as much as possible. So I will give you an example. We have here a login authentication test. So you will see the abstraction that we saw is that we want to have page objects. This is a design approach for functional testing. Each page of our application needs to have the complexity of the K6 API. We need to hide the API, and we need to make sure we reuse things, and we have some abstraction on top of our test. So you see we import the login page over here. And the actual function of the test, we start the browser from K6. You will see we don't have any K6 API calls anywhere. We call the login page, and we do stuff with our user. If I go to the page, which is actually under a different folder here, you will see the main function that hides the complexity. You will see a bunch of stuff from the library. The main idea, this is the abstraction that we did with the QA team. The main idea is that we wanted also to have stable results. If we have flaky tests or flaky execution, everybody's annoyed. So what we did is we worked together with our engineering teams to have stable, unique locators. So if you hear the term locator in web automation, it's like we refer to elements in the DOM of our application. So we can actually use and do some simulations, etc. So this is K6 behind. We use, you can use CSS, XPath, it doesn't matter, but they need to be really stable. So this is the one part. The other part is we wanted to feed data to our tests. We didn't want static data. So what we use is secrets. We use a tool called SOPs. If I can find the YAML here to show you, yes, this is a basic example. So SOPs is a tool to decrypt and encrypt secrets. You need to have access on your GCP keyring, so be careful about that. When you deploy, of course, we need to have a Helm chart to decrypt these secrets. So for that reason, we have over here a values YAML for the Helm chart. So you will see in this particular example in the Helm chart, we can override these secrets, these variables for our tests. So we have different variations of the same tests, and we override, for example, the URL that we need to navigate to our application to support multiple environments. So I can run my tests on staging or production, for example. You can have different schedules, but this is a typical example of a Helm chart and how we actually override these tests. Be mindful, these tests are running constantly. Like every 5 minutes, Dionysis will talk about this. We have a cron job for that. And the last part is what we actually monitor here, or what are these tests are doing. So there are two things that we want to validate. Functionality, if it's broken. Be careful, you don't want to test everything with K6. We use Playwright to do functional testing. K6, it's not like we want to cover everything for our application. We test basic cases, and we want to make sure functionality is not broken constantly, and the web performance is not decreased, because K6 can provide metrics for this. And the last part is, OK, what about visualization? I mean, what we are trying to visualize. We created a dashboard, which is here. OK, this is coming from the community, which is great. We just use it to extend a little bit some stuff and make a more developer-friendly dashboard for our engineering teams. You will see the Google Web Vitals. Do you know Google Web Vitals, what it is? The core Web Vitals, anyone? Raise hand. Yeah, a lot of people. OK, it's a way from Google to monitor the page experience, And K6 is really good because actually in the latest versions, they can export this, and we export them on a Prometheus server, and then we can actually fetch them on our Grafana dashboard. We use heat maps. The heat maps is a nice addition because you can see exactly the data point that it's failing, for example, and we can actually go with our engineering teams and figure out what's the problem. We have another widget because these tests are running every 5 minutes with a cron job, which is the top left. So we can see how many tests are failing, how many times our tests are actually failing. So that will be the interesting part. OK. Sorry. Yeah.
All right, let's have a look at some DevOps things.
It's not nice. It's cool, right?
All right, OK. With production out of the way, we have to solve several difficult things. So the first one was what about local development? We wanted people not having to worry about Helm charts, about difficult kind of things. And the main question was how would engineers test their new scripts? And we want to automate, again, as much as possible. Because Wake Up in the backend is doing loads of stuff with secrets, recoding, decoding, variables. We wanted to make this completely seamless for the engineers. We wanted to be able to try this thing locally. So initially, we started by wrapping all the Kubernetes logic behind some makefiles and behind some bash scripts and make it very easy for people to run their tests. First, we started by creating a Docker file for ARM architecture. We're using Mac OS, and K6 had some weird things that we needed to fine-tune for local development. Other than that, again, everything is under makefiles. People could run simple commands and then build their template or debug with shell or just run. And those things under the hood, they will encode things, override secrets, override environment variables. It's going to be very, very seamless for the engineers to test stuff. So let's give it a try, and then we can have here. So let's say you're an engineer and you just want to run your very shiny test about if a user can log in your platform. You just have to do make run, and then the scripts will take care of everything. And then it's going to take a few seconds for things to run. Hopefully, it will not fail. And then K6 will just export some, OK, let's see. And then K6 will show some metrics, and those metrics will also be exported to Prometheus as well. Okay.
Fast internet connection here today, guys.
Right.
So, just stop Wi-Fi. I mean,
Normally it takes a few seconds. So even, okay, so it failed. Failing is fine, it's fine, it doesn't matter, it always has to do with network. Don't forget that this brings a browser, and then it actually tries our platform, okay? So it can fail for a few things in there. But anyway, this is a good case because it failed, and then we can see why it failed, we can see all the logs here, and then we can either rerun it or fix it or proceeding. And this, for the engineers, this is a very good approach. They don't have to worry about anything that's going under the hood. So with this thing in place, the next thing to test out is what is actually happening when a cron job fails. And before we understand what is happening, let's have a look on the cron job object itself. So if you are familiar with Kubernetes, it's nothing too technical here. The interesting thing to see is the backoff limit of 3. So because those cron jobs are connected with alerts, with on-call teams, more than one, you don't want to have flakiness or like loads of false alarms when you bring your attention to the engineers. So with the golden rule for us is if a test fails 3 times, then it definitely means that something is off, okay? So we try each job 3 times before we say that something is wrong, and then we need to notify people. So this one is interesting here. Other than that, the rest of the object, it's for someone who's familiar with Prometheus, it's nothing major. The only very interesting thing to see is the screenshots folder. So in order to give as many information as possible about what is going wrong, we take advantage of K6's ability to take screenshots if something is failing, so engineers can use it, or for debugging purposes to see what's happening really under the hood. Some of those scenarios can be very, very long, okay? So loads of things can go wrong in there. Now, K6, the problem is that K6 is not Node.js, even though it looks code like Node, which means that we cannot just take a screenshot and then just use a GCP plugin and then upload it to GCP. Unless, okay, there are a few things that we can do with this. We can compile K6, so it includes the library, and maybe it will work. But in our case, we're DevOps people, we want to automate stuff, we have other alternatives. So we save the screenshots locally, and then we, on a persistent volume, on a PV in Kubernetes, and then we just connect this PV with a GCS bucket. So here we can have a look in the storage class, Helm chart, and then we can see the provisioner that is responsible for it. Okay, there are multiple provisioners. So in this case, again, we just store a screenshot with a specific name, and then we upload it to GCS. Okay, and this is how our cron job is looking like. Then the last part before we move on is the alert manager. Okay, what's happening with the alerts? What's going on in there? So in our clusters, we have alert manager, Prometheus alert manager, that's just sitting around and then looking for specific CRDs. This is an alert manager configuration. It looks fancy. It's doing something very simple. It just says that all the alerts on this specific namespace will just go on this specific receiver here. And then we want our engineers to have complete ownership of their applications, so everything is under Helm charts. No DevOps have been hired to write this kind of configuration. Okay, engineers, they are solely responsible for this. Now, in production here, we would probably have also Ops Genie configuration, but we omit it. So, it's going to be smaller. Yeah, so in this case, it just points stuff to a Slack channel, nothing more fancy than that. So this is our alert. And then for the Prometheus stuff, it's similar. We have a Prometheus rule, CRD. Prometheus is just waiting for specific configuration as well to be able to use it. And we just leave the expression to kube metrics. So all the difficult part to figuring out if a cron job is failing or not, we just leave this thing to kube metric. It would be interesting to see Grafana 11, if we just feed it this specific Prometheus rule, how what's going to come up with. So maybe we can come back to this. But yeah, it just says if something is failing, just raise an alert. Now, something that's interesting also to notice here is that we don't wait to fire an alert. Normally, you are waiting for a few minutes just to get rid of the flakiness. But don't forget that we have already retried our cron job 3 times. Okay, so if something is going wrong and it's failing 3 times, then you just fire the alert right away. Okay, something other interesting to discuss is how we push this data from our cron jobs to Prometheus. Because normally, Prometheus, it uses the pull model. So it just pulls stuff, it pings your service every X amount of seconds to pull data. Now, our cron jobs, now it failed, but normally they're really fast. Okay, they take just a few seconds. So it's quite possible that the cron jobs will not be up when Prometheus decides to pull them. And the reason, the way you can fix this is by having a gateway in between. So cron jobs send stuff to the gateway, and then Prometheus pulls gateway. Now, we didn't go down this route. It has some downsides for us. So instead, we used K6's ability to use a remote write for Prometheus. But for this, it's an experimental feature in Prometheus, and you need to have it enabled in your server before you can be able to use it. But yeah, K6, remote write, goes right away to Prometheus server. Everything is working out of the box. All right, let's take a step back. We have a cron job. It's doing something very simple. Brings up a K6 browser that logs the application, tries to log in, and then it gives thumbs up if it's working. Otherwise, it's failing. If it fails 3 times, cron job is failing completely. In this case, Prometheus, this will fire. And when this fires, then the alert manager in this namespace will see that something is happening, and then it will just create an alert for it. Now, let's have a look how those alerts look like. Here we have a test. And it has like loads of nice information about it. Let's say you're a non-kernel engineer, you can see right away when it failed, why it failed, clusters and stuff like that. But the interesting thing in here is those 2 lines. So you can visually see the error. Yes, it's me. Yes, that's my password. All right.
I think we don't see it.
Let's try again.
Okay.
Okay. So engineers have visual cue about what went wrong. In this case, we just changed some of our secrets to show like another random user. So it's failing. Okay, it's failing well. So engineers can just go there and see what went wrong in the first place. Now, most of the times, that's not going to be a surprise. We just have blank screens in there. So if something's taking a while to load, if something throws an error, it's difficult. And visual cues, they're nice for debugging, but they're not very nice if something really goes wrong to your application. Then in that case, people have also here, they can check the logs, and they will go right away to Loki. And then Loki here will have all this nice information that we also get from the cron jobs, and then they will figure out what is wrong and further debug. Now, engineers, don't forget that this is out of the box. We didn't do anything special. Like, everything was supported for the rest of our applications as well. And this is why it was very fast for us to iterate on this. So we also have profiling in here. So if for some reason you want your tests to have profiling, Pyroscope would be in here. Or if you had traces, Tempo would be in here. Most of the times for tests, we don't use profiling or tracing. But anyway, if you want, this stuff are supported out of the box.
Cool.
And that's it. We're going close to the end with some challenges.
All right, I can work it for. We have some minutes, hopefully. Yeah. So first challenge: QA and observability and DevOps. Right. This is what we started. As I said, not all of the companies are having quality in their process, and we started to to think about how the quality engineers can benefit from observability in the first place. So if you have observability and quality teams, you already know where you are. If you don't, you need to ask yourself, what is unknown, what we are trying to cover, how we can alert teams. And actually, the mindset of a quality engineer, especially when he's doing exploratory testing, is to understand, what's wrong with the application, why a new feature is not working. And these conversations are actually really happening with our DevOps team. And this is how we actually give birth to, to the Wake Up project in the first place. So we need to embrace the unknown.
One thing we kept asking constantly ourselves was, why build it internally? Why not use an external service, a paid SaaS service for this? And obvious answer here, it's money. Similar services, they can get very expensive. They charge per scenario. And we knew in our cases, scenarios would have plenty of them. So it can escalate very quickly. Also, don't forget that was a pet project for us, and we had to really bypass all the budget discussions, the difficult discussions and stuff like that. Also, we have made so much effort internally to have everything under the same platform by using Grafana. It was a lot of effort, to have people just logging on one thing for everything. So it felt weird just to have an external service just for this edge case. And last but not least, we really did not make anything new. Everything was already in place. All the dots were there. So it was no effort for us. Also, engineers and QA engineers were already familiar by using K6 to write tests.
Challenge accepted. So the Jane traction, we built it. The engineers need to use it, right? So 3 main pillars here. We have our project, which is a wake up. It's nice because we should tell about the name in the beginning after the lunch to wake up people. So we have people, they need to use it. We have the process. We need to integrate it in our delivery flow. So for the people, it's really easy because our front-end teams were writing React in TypeScript, K6 browsers on top of JavaScript. It has also TypeScript support, so it was really nice and easy to use it. Our QA team using it for already building load tests for the backend. The main was the backend engineers that they had a different programming language, but the learning curve was really nice and smooth. So the process is you need to have strategic goals with your business. So meaning that, OK, what is the goal here? We need to measure web performance, right? And that's the whole point. The business needs to be aware that it's really nice. We need to have page experience, user experience, and not any issues with our performance. And last but not least.
And the last thing, the one that drives me crazy lately, is endless fine-tuning. Especially with Web Vitals in place, you need to fine-tune your scripts a lot because you really want to avoid having false alarms and flaky tests. Because it's connected to many on-call teams, people can get very irritated, which makes completely sense. So as an engineer, you have to be very, you need to fine-tune your tests a lot. So with the way for us to solve this thing is by having very strict processes around it. In Wakeup's case, it means that when you're writing a new test, you fine-tune it, and then it needs to live to a Slack test channel for a couple of weeks or a couple of sprints until people give a thumbs up that it's stable enough to get into the production rota. But it drives me crazy, really.